Okay. Hello, David. David, Himmelblau Mulder is going to talk about,
My middle name is not Sky Blue.
David is going to talk about the Himmelblau project and Intune. Welcome. Thank you.
I'm not done. So I think this is probably a good follow-up to Case's a talk about group policy, because Intune is the replacement for group policy, really. Some of the group policies can be migrated into Intune. There's some free advertising for you guys at Microsoft, but not all of them. Unfortunately, we can't migrate our Samba Linux client group policies into Intune. But how do I? Oh, I forgot my clicker. I just realized it's in my bag. Can somebody run me my bag? So in my talk today, I'll talk about some of the protocol prerequisites. I'll step you through the actual the protocol steps, and then I'll show you a packet demo, packet capture. My talk's going to be really heavily focused on packet captures and specific details about the protocol, not so much about the actual high-level user experience. But I'll show you a little bit from the user experience view. So first of all, what is Himmelblau? It's a Entra ID and Intune integration tool. It's kind of the next generation of Active Directory and group policy, but in the cloud. And Himmelblau is the Linux integration for that. My original goal in starting this project was feature parity with Microsoft's Intune for Linux, and improving on that and providing user integration as well. Users have reported to me that Himmelblau is not only better than the Intune for Linux app, but it often is better than the Windows experience. So Himmelblau is open source. It's GPL3, and we support device registration and enrollment with TPM-backed device trust, which is important to a lot of users. Integrates with Intune using the same protocols as Microsoft's app. It forces policy behavior. Yeah. I was going to point out something. Anyway. I'm a little jet lagged. I mean, Douglas, I'm sure, is far worse than me. 50-something hours of travel for him. It was only 16-ish for me, but I'm still a little frazzled. So one of the goals of the project recently has been to kind of provide an off-ramp for Entra ID and Intune, because some users are requesting this capability because of sovereign cloud concerns. So recently, Himmelblau has started integrating with providing OIDC integration, so that it can integrate with Keycloak, for example, as a service provider, identity provider. The main goal is to be with this current project is to be able to provide to preserve the expectations of the from the current project with MFA integration and single sign-on and so on. We're not there yet, but we're working on it. The idea would be to reduce the cloud lock-in risk, and so that you can have a private cloud for your authentication. So first, let's look at the prerequisites. So each time we call into Intune, we need access tokens for 3 different services that we communicate with. We need to be able to communicate with the Microsoft Graph to discover our endpoints. And then we have the Intune endpoints for enrollment, details, policies, and status, which we need a separate token for. And then the compliance info service, which is something called the IW service. I don't know what that stands for. And so let's start with the enrollment process. To begin with, we send a discovery request. This is actually a specific graph request that we send. And that app ID in the request URL is a specific URI, or is a specific application ID for Intune itself. And when you call this particular request, it returns about 100 different service endpoints. I know what 3 of them do. But those are the 3 that Linux is using right now. But there's a lot that we could discover, and there's potentially more behavior that I don't understand. So it returns a JSON blob that we can parse, and we grab the provider name and the URI for each of these 3 services, which is the enrollment service, the device check-in service, specifically the Linux ones, and then the IW service, whatever that does. And we persist those for use later. Now the actual enrollment, we contact that enrollment service, and that's round robin. It's not always the same server that we're talking to. And that's why we have to do this discovery request ahead of time. And we send the enrollment request. This is a separate step from enrolling an Enter ID, because Intune is a completely separate service and you have to enroll again. Parameters, these were a little bit difficult to figure out. The API version is always set to 1. The client version, though, is a specific client version that must match one of Microsoft's built binaries. And if it doesn't match, then the request will fail. And we send them the app ID again in the request body. It's a JSON blob and a CSR certificate signing request. And the certificate signing request is one that we generate, and then Microsoft will sign the certificate and respond with that certificate to us.
It's not encrypted?
It's over TLS. So technically, yes. No, the blob that's returned to us is not encrypted itself. So the response, we get back this cert blob and a device ID. And then, of course, we have the TPM associated key that we use to create the CSR to begin with. Now, the interesting thing is in Enter ID, we need the certificate response from the Enter ID enrollment in order to authenticate. But in Intune, we never use that certificate. On Windows uses the SOAP protocol, and you do have to have that certificate in order to authenticate to the Intune service. But in the Intune for Linux service, we never use the certificate that's returned in the enrollment request. We actually authenticate using OAuth 2, which is interesting. I've never seen the Microsoft Intune for Linux app ever use that certificate either in its protocol talk. So my assumption is that this is just an artifact of Windows enrollment. It could be at some point they intend to use it, but right now there doesn't seem to be any purpose for it.
Oh, we shouldn't drop it, right?
No. It's stored. Yeah, it's stored. We keep track of it, but never use it. Maybe sometime in the future there'll be a reason for having it there. So let's talk about device check-in. So the life cycle of Intune is you enroll the device once, and then every so often you do a check-in. And the check-in validates that the device is still compliant with policy, and the policies might change. And we start that by sending a list of device details, which it's kind of interesting. Every time that we do a device check-in, we begin that by updating all of the device information with the OS version and distribution and such. And these only populate data in the Intune web interface. They don't affect policy at all.
What do you use to authenticate here? Is this the key, the TPM stuff?
We're authenticating using OAuth 2. We have an access token for the Intune service at this point.
On behalf of the user?
On behalf of the user.
So you can rewrite the payloads, like pretty much at every call you can change who is the manufacturer?
You could. Yep. On the next call, we send this policies request with the Intune device ID that we received during enrollment. Again, we don't need the certificate, but we do need the device ID that was returned to us. And and this specific call sends us back a giant map, JSON object of policy information. It's the policies that we have to apply for the device to be compliant. And then, of course, internally we convert this to a status response, which you'll see in a little bit later. But the idea is we store that policy information, and then we'll step through it and ensure that all of those policies are being enforced. This call, by the way, is much like the beginning of a GP update in Active Directory. So onto the policy application, which I refer to as client-side extensions because I'm used to group policy. So here in the bold, you can see the steps we're about to do. Not bolded is what we talked about a moment ago. So this is just kind of the overview. So next, we're going to go through all of the policies that we received, generate a set of statuses of policy compliance, and then we send it back to this status endpoint. And then there's this compliance info check step that we have to wait a moment. We can't check immediately. So now I'm going to step through the different policies, client-side extensions. So we get in the policies response, one of the ones we get is this custom config extension. These are scripts. So in it we have an execution context, which is either as the user or as a root, a frequency of execution and an execution retries, so how many times we should try until we give up, and then the actual script. This particular policy is interesting because Microsoft's response, what they get back, doesn't actually say what happened with that script. They just get back a yes, it succeeded, or no, it failed. So what we do is we apply a cron job. So we set this cron job that executes on the specified interval, and we'll try over and over again. And so, and then we respond back that we created this job, and that's really all we do.
It would be good to change that to system deep timer.
Yeah, we could do that. I've talked about doing that.
The reason for that is that it gives you predictive execution environment, and also you can harden it down.
Mm-hmm. Yeah, I've had user requests. I haven't done it yet, but yes. Cron was easy, but old. The next is set of policies is the compliance policies, and in the extension we get these Linux distribution settings is the first one, where you can set the permitted distributions and versions that the user is allowed to install. Interestingly, Microsoft only allows you to set Ubuntu and Red Hat as distribution versions. And then it also contains the password policy, where you can set the minimum, maximum, the number of digits in the local user password. Now, a local password is kind of irrelevant to Himmelblau because you're not authenticating using a Linux local user. You're authenticating to Entra ID. So I actually apply this to the hello pin right now, which doesn't make a lot of sense. A couple people have complained, so I might change that. But the Linux password policy doesn't really apply in our case because it's talking about something that we don't do at all. And there is a workaround to this, the distro limitation, and that's with custom compliance policies. So custom compliance policies essentially let you describe and set any policy at all. And this is where we break out of the very tight confines of what Microsoft's Intune provides, where we can actually describe anything that we want. And in this policy, we supply in the Intune portal, we supply a discovery script, which will be executed on the host immediately. And then we supply in the Intune portal, you'll supply the appropriate response and what Microsoft is expecting to get back. And so here on the host, all we do is execute that script immediately and send the response to Microsoft and say, compliance state is unknown, because if the script executed successfully, we don't know if the compliance state was successful because we're simply responding with that compliance state to Microsoft, and then Microsoft determines whether or not the device is compliant based on our input. This is a better policy behavior, in my opinion. This is probably the best way to apply policies because you have a lot of options. Okay, the final step, well, there's one after this, but the final step is to return all of that status information to Intune. Along the way, as we've applied the policies, we've collected them in a JSON, and now we send that back to Microsoft in this blob, and then the Intune service determines the compliance of the device. After this state, Intune will start, it polls periodically. Sometimes it's very slow. I've seen it take days to detect that the device is compliant. Most of the time it's only about a few hours. But eventually it normalizes, and you can see that the device is compliant in Intune and, or not compliant. And then the authentication behavior in Entra ID changes based on this compliance state. So if you have an enrolled Intune device and your policy is set as such, you may be denied Entra ID authentication. So at the login prompt with a Himmelblau device, you may be denied authentication within 30 days if you don't bring your device compliant. Now, many of the policies we could force compliance, like the password policy, we can kind of just enforce that somehow. But there's also a disk encryption policy, and we can't force the device to be encrypted. That's something the user will need to fix in order for us to detect the device is compliant. I believe that the default is 30 days you have for the user to bring the device into compliance. And then there's also rules on Intune for sending out compliance emails so that the user knows their device is non-compliant.
Is that default configured at the moment?
I think it is in Intune.
Okay, because it will listen to the Intune and follow up with the Intune configuration, right?
What's that?
Because I know that in Intune we could set up the group that would, for example, put users in a whitelist, allow them to temporarily log in, or set after how many days the compliance kicks in and so on. So does the Himmelblau follows up with the Intune settings completely?
Yeah, Himmelblau is just authenticating to the Entra ID service. So those policies you set in Intune are enforced automatically. Because when we call out to Entra ID and we request authentication for a user, if they're non-compliant and there's policy enforcing that they can no longer authenticate, then the authentication is going to fail. Even with Hello PIN authentication, because Hello PIN authentication is is actually an online auth. So unless they pull the cable and do offline authentication, they're not going to be able to authenticate. And even then, SSO will break because you can't refresh a token if compliance fails. We end up getting an error back from Microsoft that denies the authentication. So the final step, sort of step, it doesn't seem to be necessary, but the Intune for Linux app, Microsoft's app, does this. It calls out to this devices IW service thing, and it gives you a big JSON dump of compliance status. I believe this is for reporting compliance state to the user, so they know whether or not their device is compliant. We don't actually do any reporting to the user right now, aside from dumping the compliance data to the syslog. But perhaps we could improve on that. All right, so, oh, and I already went over this. Point was, the reason why we do compliance is because authentication is affected by the Intune compliance. Okay, now I'm going to do I want to do just a walkthrough, packet walkthrough, and show you what this looks like on the wire. And this is a man-in-the-middle proxy of everything I just described. So this is the first packet that we sent. This is that discovery. This is a request to the Microsoft Graph. Oh, you don't see it. Give me a moment, I'll mirror it. Now you see it. Sorry about that. Okay, so this is the request to the Microsoft Graph with that Intune app ID requesting all of the Intune endpoints that we can talk to. And like I said, it has this giant dump of many, many, many services. And if you look here, for example, there's the Linux device check-in service. There's also various services for like Apple devices and Android devices, and there's services defined for just about every type of device that interacts with Intune. And then we of course keep track of that. And like I said, these service URLs are being round robined to different servers, and this is not always the same server response, so you have to check that each time. And here I'm actually scraping the package version so that I'm always selecting the latest version. Okay, here's the first call to that service that we saw in the discovery request. This is the enrollment request. And in the enrollment request, we specify that app version, and I send it the certificate signing request, and this is just a test machine. Would it help if I blew this up a little bigger, maybe? I think I'm gonna make it a little bigger. Sure, a little better. And in response, you can see we got that certificate that we don't use, and then the device ID. Yeah, it's sending it as just a raw blob. Okay.
I have a feeling that it's written by different teams without
Probably.
like a common style.
What is this one? This would be probably a token. Yeah, that's a token request. Okay, and then here is the details. So I'm supplying the device details here. For this device ID, I've got a device name, manufacturer, distribution, etc. And it just responds with this useful message. But this is the correct response, the expected response.
The device friendly name is something that is in the Intune interface that supposedly user can
I tried assigning to that. It doesn't let us. I also tried different attributes. There's a whole bunch of attributes on these devices in Intune. We can only assign to those 4 attributes below the device ID. Everything else I've tried, it rejects. Now, I think some of that is because of some just legacy carryover, because you have Windows and Android and Mac and iOS. All of those devices are enrolling into the same service. So there's a lot of attributes in there that only specific device types are allowed to insert attributes to. So for some reason, Linux is restricted to those 4 attributes. And there are a lot of other attributes associated with those device IDs. And when you pull up, and I'll show you in a moment, when you pull up a device, you can see all of these attributes on a Linux machine, but you cannot set them, and they are empty. It's kind of bad for user experience, but we can't, at the moment, we can't set those attributes. So until we can, it's going to be missing that. So for example, on a Windows host, you can set the amount of available RAM, the size of the hard disk. You can set all of these attributes so administrators can filter by them and check various device components and stuff. But on Linux, we get to set those 4 attributes, and that's it. Here is the policies request. This is mostly an empty request. We just send the client version and such. But in the policies URL you see here, we have the device ID again. And in the response, we get this big JSON response. And this it details every single policy that we need to enforce on the device in order to mark the device as compliant. Like, for example, here's a script execution frequency and the execution context. See, this particular script has a user execution context. Let's scroll down and see some of the others. Here's another policy. This one is the compliance policy. This one's allowed distributions. It looks like we've got it set to min-max. Those look like Ubuntu versions. Yep, it's set to Ubuntu. And then we have a discovery script, which is just a base 64 blob of the script. I think it just like echoes something. That one's not doing very much.
So how big is this response?
That big.
I mean in kilobytes.
I don't know.
10.4 something.
Oh, 10.4 kilobytes right there. There you go.
We were talking about packs and characteristics.
Okay, here's the next call. This one is for the status. So this is when we've completed checking the status. And this test script that I have sent, it just dumps nonsense in the response, actually. So it's going to come back as non-compliant. Just forewarn you. This isn't a real packet capture. I was being lazy. So we'll respond and say, it's all compliant. That's what I did. Which you're not supposed to do with a custom compliance script, but I think it did anyway. And then in response, we get, it just echoes the same, it echoes back at us, which is interesting. And then we have to wait a few moments, because if we request the policy compliance state from the IW service, whatever that means, immediately after we've sent the compliance status, then it doesn't have the chance to record the compliance state. So if we wait a few moments, and then, I'll go back and show you this. This is the IW service here, and you send a device command with the GUID of the device ID and some other magical numbers. I don't know what some of these mean, but they're always the same. And then it responds with this blob, this JSON response with, now these are interesting. I have tried calling into some of these APIs that it's got on here, You can retire the device or delete the device using these commands. So these do something. Some of them I was able to figure out how they operate and what to do with them. Some of them I'm not sure yet. But then it also it lists all of the non-compliant rules. And it's going to say custom compliance isn't compliant because I didn't respond correctly to the custom compliance. And then, yeah, there's a whole bunch of, it responds with a whole bunch of different attributes of the device, which are the attributes we're not allowed to set, a lot of them. And that is basically it. In my test here, I have it run a few times, but we don't need to go over that. But that is how the protocol works, just on Linux. On Windows, it's completely different. On Windows, it is a SOAP protocol, doing essentially the same thing using a completely different protocol. I assume the other Intune devices are like Android and iOS are also different, but I haven't investigated those protocols. But they're in that big list of device types that we discovered. I'm going to pull up now the Intune Admin Center. So this, I believe, is the same machine that I created with that test script just to test it out. And you'll see the compliance actually failed because it didn't know how to read the response, the junk response I sent to it. But bad example, Himmelblau actually does respond correctly, and then this would show compliant or non-compliant. But then we get the operating system field, we get the device manufacturer, you see that. Everything else is basically just blank. We go into the properties, they'll have a list of some other things. Oh, no, that's not what I meant to do. These are some that we can set. Hardware is what I meant. Hardware, you'll be able to see some of the other values. I'm going to blow that up a little bit. So again, operating system language, edition, patch level, memory use, IMEI, manufacturer. There's all sorts of things in here which we're not allowed to set on these Linux devices. It would be nice if we could. If we go to device compliance.
Not allowed, you mean even in Microsoft Intune client?
Yeah, the Microsoft Intune client can't even set them. So if you go to device compliance, you can see this one's failing. That's the policy where I intentionally sent garbage response and it doesn't know what it means. So that's expected. And then this one, we actually have some valid policies here. Enrolled user exists, compliant is active, compliant has a compliant. Oh, those are the basic ones. Okay. So some of these show up as compliant. Yeah, that's basically it. You find these in the Microsoft Intune Admin Center. If you go by platform, there's Linux devices, and you can see I have 2 little test devices that I threw in there. Yeah, well, are there any questions? I'm finished otherwise. Yeah.
How far can you go?
Thanks, sir. So how far can we go with those scripts that are checking the policies? So we can run shell script there. Anything else? Like, can we do the executable?
Everything you can execute. So, I mean, theoretically, you could upload a binary executable to Microsoft's script tool. I haven't tried it, but I imagine it would work. Personally, I've used Python scripts and shell scripts, and anything that can be executed, Himmelblau handles properly. The Intune for Linux app, Microsoft's tool, does not. It's not very robust.
Yeah, so all that matters is actually the response from that script, like whether is it successful or failed, or in JSON, I guess.
So with the scripts policy specifically, it's just checking if you are executing that script on the host. That's all it wants to know. You're compliant if you are executing that script on the host. With the custom compliance scripts, or custom compliance policy, which is also a script, then it is you execute the script directly and then respond to Intune what the response from the script was. And then Intune determines whether or not that matches the expected response, which you specify in the Intune portal. So for example, it could be a script that checks if the device has an encrypted disk, which we already have that policy, but just for example, checks if the device's home directory is encrypted or something, and maybe the script just dumps to the terminal true or false, and then to be compliant, the compliance requirement in the Intune portal would be just that it prints true.
Thanks.
Okay.
If using the Linux interface, specifically for Linux devices, is limited, you can't update all the fields and stuff like that. Would there be anything to be gained from enrolling the devices, the Linux devices, as Windows devices?
I've been down that road. It doesn't work very well. So if you enroll the device in Enter ID as Windows, and then as Linux, and then enroll the Intune device as a Windows host, so that you can try and change those properties, then it actually resets the Enter ID device and makes it a Windows device, and then stuff breaks. And if you try to communicate with the Windows API, the SOAP protocol, to try to talk to Intune to set Linux policies, it also barfs.
Is there any way, so this assumes that the endpoint device is solely responsible for its communication. Is there any way to have some other device to represent a fleet of endpoint devices which cannot communicate directly to Enter ID and Intune endpoints?
I think you're asking because you're thinking about free IPA. I think we've had a discussion about this before.
Yeah.
I think that would be possible. So where you essentially are supplying all the device information that you've retrieved from another device, but your service is not actually the endpoint device. You would have to enroll in Enter ID and Intune from your service, and it would be essentially pretending that it's the endpoint, but the endpoint's over here. I think that would be possible, yes.
So we need to relay compliance execution to the other systems, but we effectively will be a relay of the Enter ID. There's nothing that prevents us from implementing some sort of relay or proxy.
Yeah, that should work. I don't see any problem with that.
Yeah. Good. Well, that's sort of it to allow you to discover the policy.
Yeah, that's kind of like what we're doing here. This isn't a real device, but Microsoft thinks it is. So, same idea. I run this multiple times on the same host, and it doesn't have any problem with that.
The other question is, how bad is the client version changes?
How bad? What are you referring to? The
So
Intune for Linux?
you have to cross-check every time that there is a valid version on the Microsoft site that you can download, and therefore you don't need to download, but you need the version string. Do you track the API changes if they happen?
I have been tracking them, and I have yet to see an API change. This has been the same for like 4 years.
Okay.
As much as I've been able to see in that time frame.
Do you envision problems when those changes start coming,
I-
effectively fighting against the Himmelblau as an endpoint.
That's certainly possible that, that there could be API breaking changes. But people in Microsoft are aware that we're doing this. And I've been in contact with some of the Intune people, and I don't think they would do that unless there was really malicious intent, which I doubt at this point. But I suppose that if they made changes to the API, that it could break it, in which case we just wire trace and fix it like we've done in Samba all this time. Yeah.
So tomorrow I will have a talk about the some of the work that we do on attestation from the services towards the centralized thing. It would be interesting to see if we can use, like in the context of this client proxying thing, to proxy the information that is valid or interested to Intune.
Are you talking about TPM attestation?
No, it's
No.
more like I'm using S4U X509, S4U to self X509 extension to report attestation certificate from the service that then can be used by KDC to decide how to issue a ticket, which might include a lot of additional activities like this one.
Sure.
But more tomorrow at my talk. The reason why this is important is that there are plenty of services that want to do protocol transition, like from OAuth, and want to get the Kerberos ticket for file system operations for the networking and other activities. Without changing or extending the protocols, there is one place where we can do that at S4U to self with the certificate identification of account.
Well, one comment about that. When you enroll a device in Enter ID, it supplies Kerberos tickets from both the cloud environment and also on-prem Active Directory if it's synchronized.
Unfortunately, they are not compliant with the Kerberos RFCs.
Yeah.
And that's official answer from Microsoft that they is not intended to be used in the real Kerberos environment.
But it does work. Samuel's actually been working on that.
For example, one of the big problems there is that the ticket generated by Entra is not having the bit that pre-authentication of the ticket happened. And it's immediately rejected on any Linux environment because by default, pre-authentication is enforced. So KDC basically rejects it immediately. So you cannot use them for like Microsoft Active Directory domain controllers do not reject them, but MIT and Himmelblau reject them. And this is.
I know there was also a issue with name casing in the response.
Yeah.
Yeah.
Yeah, David.
Whoa.
I believe that you said that you were able to manage TPM attestation. Is that right? And if so, can I pay you a beer at the bar just after your presentation?
What's that?
Can I pay you a beer so you can talk to us about TPM attestation?
Oh, he asked about attestation. I asked if he was asking about. No, we're not actually doing TPM attestation yet. It is possible, but it's not documented, Microsoft people, and so I don't know how to do it. If it were documented, or if I spent some more time hacking at it, I might be able to figure it out.
Okay.
But that particular bit in Enter ID, it happens during the Enter ID enrollment. You can do TPM attestation as part of the device enrollment. And I know what fields you need to provide, but I do not know the formatting of the TPM attestation.
you still want a beer.
What's that?
You still want a beer, we need to talk about together.
I don't drink alcohol, sorry.
I'll get you a Coke.
That'll work.
Yeah, so I just wanted to say one thing, because I see that the room is full of programmers. You're thinking about the protocols. You compare Himmelblau to the legacy technologies and so on. From the end user perspective, using Himmelblau, we were able to build the image that goes to the end user out of the box and has one single company-related information as the company domain. So if your company is company.com, that's the only thing that you have to specify. You can deploy Himmelblau, and as long as you have Enter ID entity, or the identity in Enter ID with MFA and so on, you can log in, no questions asked, and then using Himmelblau, you can run the compliance checks, you can register to Intune, many, many things. So,
And single sign-on.
and single sign-on, exactly. So it's incredibly powerful tool. It's doing the magic, actually, in my opinion. So thank you, David.
Thanks.